Hello and welcome back to lesson 2. In the last lesson, I asked you to write out electronic configurations for elements 1 to 20. In doing so, depending on what kind of periodic table you used, you might have been faced with this small dilemma. If you used a very simple kind of periodic table, then you would see carbon as 12,6, or the number 12 associated with carbon. But most periodic tables, of course, don't just have a 12. They would have 12.01, and some of them go on to have more decimal places after the 1. Where does that come from? Perhaps our teacher might have simply told you, just round it up to the nearest whole number and treat that bigger number on the periodic table as the mass number, being equal to the number of protons and neutrons. And that works out very nicely. But of course, there's an explanation for all of this. What's listed in the periodic table doesn't represent a particular element, because all of these elements don't exist with only one type of atom. There are different atoms of the elements, or different forms of the elements, or different isotopes of each element. By far the most abundant isotope of carbon in the world is carbon 12. But you've also got carbon 13 and carbon 14 and small amounts of other isotopes. What are these isotopes? They are the same element, but there's a difference in the neutron number. Take, for example, chlorine. 17 protons and 17 electrons exist in all chlorine atoms. But approximately 75% of the chlorine atoms contain 18 neutrons and 17 protons, giving a mass number of 35. But then you have got another fairly abundant isotope accounting for almost 25%, and that other isotope is chlorine 37 with 20 neutrons and also the same proton number, 17 protons. Proton number must be the same in isotopes. What's different is the number of neutrons. The number of electrons and the electron configuration, all of that remains the same. So this 12 here that comes with a carbon, what is that 12 really? And why is it referred to as an atomic mass, abbreviated as AR? Why is that referred to as a relative atomic mass? And the reason is because carbon atom, a carbon 12 atom, was set as the baseline for creating a particular unit that would be used in the periodic table. And 1/12 of the mass of a carbon atom was designated as one atomic mass unit. So everything else that you want to find the relative atomic mass of, it's how many times it's heavier than this one atomic mass unit, which is just like 1 centimeter or 1 meter. It's a standard unit of measurement. One atomic mass unit equals 1/12 the mass of a carbon 12 atom. So one atom of chlorine 35 is 35 times as heavy as one atomic mass unit. Carbon doesn't have a 12 in the periodic table because it exists with other isotopes. And the number that's given here is the average of all of the isotopes. That is the number that's put in the periodic table. So for chlorine, for instance, you would go to the periodic table and you would see 35.5 as its relative atomic mass. And this is the abbreviation for relative atomic mass, AR. You would see 35.5. Where does that come from? And it comes because 75% of the chlorine atoms approximately is chlorine 35, and the other 25% approximately chlorine 37. So you do the maths like this: 0.75 or 75% multiplied by 35, and you add that to 0.25 multiplied by 37. Adding these two up would give you a final total of 35.5. And this is how you would go about finding the relative atomic mass that gets listed in the periodic table based on the relative abundances of the isotopes. Now, we should bear in mind that chlorine has a lot of isotopes. but these are by far the two most abundant. So for simplicity in a question, we say 75-25. When there's a small fraction of 1% that makes up all other isotopes, that doesn't affect the answer too much, and that is why 35.5 approximates the answer for the relative atomic mass of chlorine in the periodic table. Now I would like you to try these questions.